Hello everyone, thank you for watching Edupedia World videos. So this is the part 2 video of SAP Performance Tuning. Okay, this is very important. We will learn about the different types of SAP response times. Okay. So STO3N is a transaction where it is embedded in the SAP kernel itself. Okay, so SAP provides the different response times of various transactions and the reports which are running in the SAP system. Okay, so there you have old data also, like up to last 2 months or 3 months you can have the old data. Okay, so SAP gives monthly or weekly based or even daily based data, and even every hourly profile also you can get it from there. Okay, so in the next video we'll learn about STO3N, but before going to STO3N transaction, okay, first we'll get familiar with what are the different types of response times. Okay, we'll have like wait time, load time, then a front end response time, CPU time, database time. So in this video we'll understand like what is this different, what are these different response times are. Okay, so the first one is the dialog step, wait time. Okay, so we have three layers: the presentation, application, and the database layer. Okay, so when from a GUI, when the user logs on to the system, it goes to the dispatcher. It sits in the wait queue unless it is picked up by a work process. Okay, so it waits for some time in the dispatcher queue. That is the wait time. Okay, so this and the following slides describe the sequence of actions that contribute to the total response time in multi-tier architecture. To complete the logon process, the presentation server connects with the dispatcher, right? So first, when we log on to an SAP system, the request from the message server, it sends to one of the application server, dispatcher. When the user tries to run a transaction, the user's request comes from the presentation server to the dispatcher and is put into local wait queue. So the user request is kept in a queue. Okay, every dispatcher has a local wait queue and the request is kept there. When the dispatcher recognizes that a work process is available, the user's request is taken from the wait queue and sent to the work process. Okay, so when a work process is available, then the dispatcher, it assigns the user request to a work process. So this wait time in the dispatcher wait queue is known as the wait time. Okay, so the total response time from the moment you log in and you get a response of the report you have executed, okay, so the entire round trip, okay, is divided into different times. So the first one is this wait time. Okay, and this picture, it clearly shows like when it's sitting in the dispatcher queue, okay, that time is known as the wait time. Now the next one is the roll in time. When a user is dispatched to a work process, so after the user task is assigned to a work process, the user context data, the user's logon attributes, authorizations, and other relevant information is transferred from the role buffer, extended memory, or the role file into the work process. This transfer by copying or mapping as appropriate of user context data into work process memory is known as roll in. Transaction processing then begins. Okay, so earlier so many times we have come across this terminology known as work process multiplexing, role buffers, roll in, roll out. Okay, so every dialog step can be executed by a different work process. Okay, so that we know. When the task of a user switches between one work process to another, in the meanwhile, after a work process completes executing, it will put all the user context data in the role buffer. Okay, or you'll have the extended memory or the role file. Okay, so when the new work process has to pick this data from the role buffer or the role file, okay, so the amount of time taken to fetch that data is known as the roll in time. Okay, so here this part is already over. Okay, so already sitting in the wait queue, and from the dispatcher it's assigned to a work process. Now it will get all the relevant information from this role buffer or the role file into the work process role memory. So work process also has some internal memory. This user context is rolled in from buffer or role file into the work process. So that part of time is known as the roll in time, okay, of the dialog step. Now, so once this data is brought inside the work process memory, then only the transaction processing begins. Now the next one is the database time. Okay, this is a very important component. From the database is required to support transaction processing. A request for data is sent to the database interface, which in turn sends a request through the network to retrieve the information from the database. When it receives the request, the database searches its shared memory buffers. If data is found, it is sent back to the work process. If data is not found, it is loaded from the disk into the shared memory buffers. After being located, the data is taken from the shared memory buffers and sent back across the network to the requesting database interface. Transaction processing resumes. Now, user has logged in from the dispatcher queue. It came to the work process. Work process has got the user context from the role buffer. It starts processing now. Once it started the processing, it might require some data from the database. Okay, so that means like in the SAP buffers the data is not there, so a database call has to be made. So in that case, the database interface in the work process, okay, in the work process architecture initially, okay, when in the initial videos where we have studied about the work process architecture, there is one component known as database interface. So this database interface, it works, okay, with the database to get the data. Okay, so even the database, similar to SAP, it also has some buffers. Okay, so first it checks if it's there in the buffer, then it sends the data to the SAP system. If it's not there, then from the disk, okay, it has to go to the database, get the data and send it to the SAP system. So all this once the database interface sends a request to the database until it gets whatever information data it has requested from the database. So this entire time is known as the database time. Okay, so one of the major component of the total response time is the database time. And generally, when we talk about efficient optimal performance, the database time, it takes up to 40% of the total response time. Okay, so if it's more than 40%, like 70, 80, okay, more than 60, then it's a concern. You have to check like why it's so high, but ideally it is less than or equal to 40% of the total time. The next one is access to SAP buffers. So why it has to make a database call? Because the data is not there in the SAP buffers. If data is there in the SAP buffers, then no need to make a call to the database. Before accessing the database service, the database interface searches for the data in the R3 buffers, right? So if data is found, it is relayed back to the work process where processing resumes. If data is not found, the database interface sends a request over the network to retrieve the information from the database, okay, as we have described on the last slide. If the data loaded from the database is eligible for R3 buffering, it is placed in the R3 buffers. Transaction processing resumes. So first thing is like before making a call to the database, it will check in the R3 shared pool buffers. Okay, every instance has some buffers. There are different buffers like program buffer, table buffers, factory calendar, all these things. Okay, so before making a call to the database, it will check in the buffers. Okay, if it's a hit, then the data is taken into the work process memory and processing resumes. If it's not there, then as we have discussed in this slide, it has to make a database call to the database. Okay, it has to access the database to get the information, and once it gets the information from the database, okay, if it's eligible for buffering, SAP uses various mechanisms, algorithms, okay, for buffering. Okay, all the data will not be buffered. Okay, there are some rules and principles for that. So if the data is eligible for buffering, then it's placed in the buffers, so that next time again it need not make a call to the database. Okay, and then the processing resumes. Now, what is this total response time? Okay, when the transaction processing is completed, the dispatcher is notified of its completion. The result of the transaction are then sent back to the presentation server. Okay, so the wait time, the roll-in time, this database time, so all this put together. So the entire round trip is known as the response time. When you talk about the response time of a program, it includes all these activities: making calls to the database, checking in the SAP buffers, getting the data from the database, okay, the roll-in, okay, the wait, in the dispatcher queue the request has to wait. So this entire, when we club up all these response times together, it's known as the total response time. Okay, now rollout. For your transaction processing, the work process gets data from the roll buffer or the roll file into the work process queue. Okay, now after the transaction finishes, the work process is no longer required. The user context data is rolled out of the work process. So that is known as the roll out time. So now your task has been completed. Okay, the response has been sent back to the user, the client. Then what happens? Whatever user context is there in the work process, it is rolled out again into the roll buffer. Okay, so that component is known as the roll out time. Now, this slide summarizes the previous slides describing the sequence of actions that contribute to the total response time in multi-tier architecture. So you have a wait time, you have a roll-in time, then you have a database request time, and all these clubbed together form the response time. Now, CPU time. CPU time is the amount of time during which a particular work process has active control of the central processing unit. Okay, so CPU time is nothing but when the actual ABAP processing is running. Okay, the actual time taken by the work process when it's actively processing your request. Okay, all these other times like wait, roll-in, database request time, they increase your response time. Okay, they increase your actual processing time. Okay, waiting time, these all should be less because they drastically increase your response time. They affect the system performance, but the actual processing when it's done, okay, that is known as the CPU time. Now the workload data statistics. So this is a three-tier architecture: the presentation, application, and the database layers. Okay, so we have the wait time, roll-in, the load time, okay, the processing time, and you have the database time. Okay, the CPU time is nothing but the actual processing time, and load time means the time. In the slide we'll learn like what are these different subtimes are: wait, roll-in, load, processing, and the database time. So the workload time statistics include the response time is in milliseconds. Okay, in an optimal performance, a dialog response time should be around 1 second. Okay, the average response time of a dialog step should be 1 second. So that is considered to be optimal performance. Okay, similarly for each task type also you will have different response time for RFCs, for background, for dialog. But because most background, see, you run a report in background and you leave it. Okay, so even though it runs in background, you are not that much worried. You are not sitting here and waiting. You submit it to the SAP system, it runs as a background, okay, and after some time you get the result. So even, of course, even background programs are also have to be, background jobs and programs have to be tuned, but this dialog response time is very important because I am sitting in front of my system, I am giving some input and I am simply waiting for the output. So that's why the system average response time, dialog response time is very important. And in optimal, when optimal performance, 1 second is the value for 1 second is considered to be a good value, an optimal value for the average, the dialog response time. Okay, so the response time is in milliseconds. It starts when a user request enters the dispatcher queue, ends when the next screen is returned to the user. Okay, the response time does not include the time to transfer from screen to the front end. Okay, so the total response time means you have given some input in your program, you click the execute button. So until you get the next screen, until that dialog step is completed, the next screen is presented to you. Okay, so that time taken is known as the response time. Wait time in milliseconds. This is the time a user request sits in the dispatcher queue. It starts when the user request is entered in the dispatcher queue and ends when the request starts being processed. Okay, so wait time is nothing but the time when the request sits in the dispatcher queue unless it's picked up by a free work process. The roll-in time in milliseconds, the amount of time needed to roll user context information into the work process. So the work process has to get the user data from a role buffer or a role file. Okay, so that is the roll-in time. Now this load time is the time needed to load from the database and generate objects like ABAP, source code, CUA and screen information. Okay, so load time means you have to generate the objects like the ABAP, source code, CUA, the screen information. Okay, that time is known as the load time. The processing time, this is equivalent to a response time minus the sum of wait, the database request time, the load, the roll-in and the enqueue time. Okay, so the processing time is nothing but the actual time when the processing is done. A database request time starts when a database request is put through to the database interface, ends when the database interface has delivered the result. Okay, so once the database interface has sent a request to the database until it gets the required data. Okay, so that entire time taken to send and get the request from the database is known as the database request time. The CPU time, this is the CPU time used by R3 work process. Okay, so the actual CPU time which is used by the R3 work process. The role wait time and GUI times are covered in the unit interface monitoring. So in the other videos we have interface monitoring. Okay, so there we'll discuss about what are these role wait times and the GUI times are. Okay, so response time means the wait, the roll-in, the load, okay, and the database time. Okay, the actual CPU time is not considered to be an additional burden to your response time. Okay, because CPU time is the actual time which is taken to process your request, and all these other factors like wait, roll-in, load and database, they actually make your response time high. Okay, so this is about the response times. Okay, so these are the graphical representations so that we can understand better. Okay, so starting from the wait time, the roll-in time, then the database time. Okay, so accessing the SAP buffers. Okay, if the value is there in the buffer, then the performance will be good, or else a call has to be made to the database. then the total response time, what it consists of, and after the work process has completed your request, it will do a rollout. So that is the rollout time. Okay, so these are the various components of a response time. And say like if our performance, when we talk about performance is bad, then we have to analyze like which component of the response time is high. Okay, whether all the reports are getting affected or if it's only a particular report problem. Okay, so depending upon these various types like wait, roll-in, database request. Okay, so you can check all these components and you can find out where the problem is. And why the time taken to present to the front end is not included in the response time, because that depends on your network speed. So that is not a performance issue of the SAP system. So that's why it's not included in the response time. Okay, see, the response time does not include the time to transfer from the screen to the front end. Okay, so once SAP has delivered the request, okay, so maybe because your laptop is slow or the network which is connecting to the SAP server is slow, so that is not something which SAP side has to deal with. The network team, or probably it's your laptop issue or your desktop issue, okay, or your cable issue or whatever it is, or your company is there is a LAN problem or a WAN problem. Okay, so that's why the front end response time does not come in the total response time. Okay, that is not that. If it's slow, your performance will be slow, but that is not a problem on the SAP side. So that's why it's not included. Okay, all the other components which we have discussed in this video, they sum up to the response time. Okay, thank you. Bye.